Today I want to look at right shifts and left shifts concerning arrays in Java. This is something that I've run into a couple times this week as I'm prepping for some interviews. I've been working on HackerRank, a couple other sites. Basically doing the typical tech interview, hey, can you solve this problem? Can you move this stuff around? I've been through a couple whiteboarding sessions, and I want to do a couple things to speed myself up so that I can get through more problems, show more of my code knowledge, because ultimately that means it's more likely I get the job and that there's probably a higher salary at the end of that. So let's jump into this. I've set up some boilerplate code to make this kind of easy to work through and understand, and you're not watching me type all this verbose stuff out because I'm already at almost 50 lines of code. So here you'll see it's pretty simple what I've got laid out. I've got two arrays. I've got a right shift method and a left shift method that I'm going to want to call. And basically, I'm going to leave this left shift method just commented out right now so that we can focus on one at a time. And basically all that we're looking at here is a problem where you would take an array and it would say, hey, shift it by 3, shift it by 4, and it may say to go to the right or to go to the left. And there's two different approaches to how we'll do that. They're going to obviously, just by common sense, involve the same properties, the same math, just kind of flipped around. So let's take a look at this and jump into it. To get started with right shift, the early numbers make perfect sense. I'm going to shift them to the right, so this being the zeroth position in this array, I obviously know that if I'm going to shift it to the right 3, that its new position is going to be 3 plus 0, which is 3. So it's going to go 1, 2, 3, which is this third position. And that's easy. And 4 is going to go over here to the 7. I'm going to run into an issue with 6, and 7, and 8, because when these need to move forward and kind of shift to the right, I'm going to need to wrap them back around. So 6 is going to go 1, 2, and 3 and be in the 1 spot. 7 is going to go 1, 2, and 3 and be where this 2 is, and you kind of see where we're going with this. So to start out, I really know that my first step is going to be to essentially give this a new position. I want to have a new position variable. And essentially I want to set that down here. The ultimate goal is that I would take that and I would say, hey, look, I want in temp, I want this temp array that I have here that I'm going to hold my results in. I want in its new position every, and actually I need to move this up in here. That's my fault. Go ahead and pull this up into here. So every time that we iterate, I basically want to take this and I want to say, put in its place the index that I'm on in the array. So each time I'm incrementing through, take this number, put it in its new position in temp. Pretty straightforward. And we already said that the easiest way to handle this is just by taking this idea of the index and adding to it the right shifts that we want to do, right? That's pretty simple. But we said once we get to 6, 7, and 8, we're going to run into a couple problems. So this is going to work all the way through here. That would be the answer, just simple right there. But then we're going to hit 6, 7, and 8, and we're going to get into some issues. Well, this is where modulus really becomes our friend, okay? And if you've seen this sign before, if you haven't, go read about it for a second. You'll totally get it. Just means, hey, do division, but only give me back the remainder, right? Do some division, give me back what's left over after I do division. Okay, and so what I want to do with this is use it to actually go and say, hey, do a math operation that's not really going to count for any of these because I already know how to get them, but would really, really apply in this sense, okay? And here's what I mean by that. Here, I want to take this modulus and I actually want to divide by the length of the array. Okay. And what this is actually going to do is this is going to take, sorry, that's not a method. I'm going to take this length and I'm going to divide this out. And so what will happen is like right here, let's take the first number, for example. I would have the 0 position, so 0 plus the number of shifts, which is 3. Okay. And I'm going to go ahead and do this math and I'm going to divide 3 by 8. Well, how many times does 8 go into 3? It doesn't. So with modulo, this is just going to be 3, which works exactly like we said it should. 1 should go from 0, 1, 2, 3, and it should be right there. That should work. But here's what's incredible about these last few numbers right here. This is actually going to kick in and help us get the right answer that we're looking for. So if you see right here at the number 8, this is going to be index 7, right? And so we're talking about 7 being the number here, plus the number of shifts, which is going to be 10, right? So we would obviously be outside of our array. But now we're going to take that 10 and we're going to divide it by 8. It goes in one time with 2 left over. So guess what we have now? New position is the number 2. So 8 went from here to the number 2, which it should. It should go 0, 1, 2, right? And now using this modular math, you have this really succinct, simple solution to this problem. That's something that you probably could just memorize or write down, kind of like treat it like a formula chart like you had in school, you know? And then at the end of this, really all I'm going to do is print out these results to say this was the array that I had originally, and now I want to print out temp and show you what I have now. So let's see if it worked. So we go ahead and run that, and we are seeing that our 1 should have went 1, 2, and 3. I see that 1 went 1, 2, and 3. 8 should have wrapped around and went to, as we said, the second position. 8 went 0, 1, 2, right? I see it right here. And so we know we got the right answer, right? This modular math helped us do something very simple. And if you had this kind of totally wrapped up, totally understood in your mind, totally something you practice, when you go into a whiteboard interview and you're standing in front of people, you're not going to be nervous because they're not going to ask you on a whiteboard to do all of this that I've done, all this boilerplate code. They're going to say, hey, if I gave you this array and I asked you to shift it 3 spots to the right, what would you do? And you would go, oh my God, thank you. So glad I practiced this. And you're straight up going to do this code like right here. Like you're going to probably have to do this right here. Right? You're just going to iterate through. You would probably write out this whole little block right here. And imagine if you already had that there. Your coding interview, like your people are sitting there going, wow, this person really knows their stuff. Like they've practiced this before. They didn't have to look this up. They didn't have to go and do something crazy. And you could really talk through it out loud and you could really show them why it works and explain it. And then you would be moving on to the next question, already having that confidence of like, I answered one of these things that I'm doing so well, and you would have that confidence to just move forward. That's an awesome feeling, and that's really what I'm working on here. So let's jump down into the next one. Not really going to take too long to explain this. We're doing the exact thing that we did up here, just kind of in a reverse fashion. We're just going backwards because we're obviously doing left shifts. So I'm going to uncomment all of this. And in this one, essentially what I'm doing is I am going to work through this backwards because I'm shifting left now. So I want to go this way so that it makes sense in my head. Instead of shifting right, I'm going this way. So now the 1's going to have to wrap around and the 2's going to have to wrap around, or depending on what number you get. Okay. Here I'm sticking with 3 just for consistency, and we'll look at what happens here. So with left shifts, a little bit different. The code here is going to be a little bit different. You're going to see, because I said we're moving to the left, rather than incrementing from 0 all the way up to the length of the array, I'm going to start at the length of the array minus 1, which will give me that last position in the array. And I'm going to work down to 0 and stop myself there so that I get the whole array just going backwards. So rather than going this way and iterating through, I'm going this way and iterating through, right? Just going to the left. Pretty simple there. So in here, I'm going to do the same exact thing. For consistency's sake, I'm going to say I want an integer. I want to call it new position. And I want to take that and I want to set it a little bit different this time, right? Because on this iteration, I'm actually going to have to move around how that modulus works and how exactly we solve this. So here's what that's going to look like. I'm actually going to take the same exact variables. I'm going to have I'm going to have the spot that we had, and I'm still going to be adding it, right? So like here we saw I have and I put it the number of shifts, and then we went by length here and kind of divided out. We're actually going to use this exact same thing here too, okay? I'm going to have array length, and I am going to divide by it, right? The only thing that's going to change is right inside here, I'm actually going to take and kind of flip this problem in a way and say that I'm going to take the length of the array and I'm going to subtract from it the number of left shifts, okay? So what this is going to do, if we look at how it's different from the one above, in this one we added the right shifts, right, because we were working up this way, and then we used our division to go back and grab what we needed to take off the necessary remainder, or just this not even really be needed or executed, just defaulting back to this right here. And that really helped us extend out and then come back to the number that we needed. In this one, we're doing something very similar. We're starting at the index, like we're starting at wherever we are here, but we're just essentially adding the length of the whole array minus the number of shifts. So think of that as like I'm going this way, so I'm going to take the whole array and I'm basically going to add on the number of shifts. So here, if I want to do, we'll stick with this one for consistency's sake. I have 7. I'm going to subtract the number of shifts, right? Right here, left shifts. So I'm going to subtract the number. So I'm going to have 8 originally. I'm going to subtract by 3 and get 5, okay? And then I'm going to perform my modulus. So what's really the difference here is that you're just going in a different direction, right? So instead of me adding up and going this way and taking away, I'm actually doing my takeaway going this way and then having that modulo pull me back this direction, okay? So instead of going this way and saying, hey, let 8 be the 7th place that's now at a 10 and use the modulus to bring me back, right? I'm actually going this way, taking away what I need, and then letting modulo bring me back. And it's cool. I like that vision in my head of like a rubber band, like modulo's pulling me back into the array, never letting me get too far. It's just, hey, I'm 8, I got out here. No, you didn't. I wrapped you back around, okay? And that really helps me cement this idea of what's happening here with this math. So I look into it. I've got this right here all worked out. I'm going to do the same thing that I did above, where I'm going to take temp. I'm going to say new position. And what I want to put in that new position is the array indices as I'm iterating through them. And I'm going to do the exact same thing right here. So we see they're almost identical, just a little bit different on how we directionally worked through the problem, okay? And then I'm going to go ahead and run this and see if we get what we were searching for. Uh-oh, I got an out of bounds exception. What did I do? I put something in here wrong. Yep, okay, sorry. This parentheses matters. So let me pull this back over here and wrap that up, and I should be good to go now. Cool. So just a little PEMDAS for you there. And I'm going to keep this in the video because, as I have always done with my students, I want you to see I make mistakes. That's something that can be easily corrected and something that you shouldn't really hold yourself too heavily accountable for. It was a parentheses, got the wrong answer. In the real world, you would have tons and tons of tests to check that, but that's a totally different discussion. So let's look at this. We've got this problem where we're going to resolve all of this. That's why the parentheses mattered. Here, a little PEMDAS, we're going to work all this out, and then we're gonna use modulo to rubber band us back in. And really, that's what I want you to think about this. You can go read about the theory behind it. You could go work through the math. You could go do all that. Really understand that what's happening there is we are doing division, and we're getting the remainder when we need it. And that really helps us just essentially return back the right answer. So here, to check our work, we said we wanted to shift this to the left by 3. So let's take 4 and go 1, 2, 3. 4 should be right here. 5 should go 1, 2, 3, and it should be in that position. Our 8 should have went 1, 2, 3, and it should have been 1, 2, 3, and it's right there. So we see we have the right answer. Just thought this was a cool thing to share. Wanted to throw that out there, have this for in the future if I'm thinking, hey, I don't remember that algorithm that I worked out. I'll have a video of it. We both learned from this, and I appreciate your time. You have a great day. Good luck.